Hello student, welcome back. Again this is Professor Amolius Kalekar from Department of Computer Science CMCS Yotma. In today's session, again we are going to discuss the new point in unit number 4 of subject distributed database system, and the topic of our today's discussion is the distributed file system implementation, and within that we will focus on the cache consistency. Students, in the earlier session, we have seen how the caching is done as far as the distributed file system implementation is concerned. In today's session, we will see the point of cache consistency. Okay, so let's start. That is the point cache consistency. So, as usual in computer science, you never get something for nothing. Again, a client catching introduce the inconsistency into the system. Okay, now in that sense, if two clients simultaneously reads the same file and then both modify it, several problems can occur. For example, when a third process reads the file from the server, it will get the original version, not one of the two new ones. Okay, and this problem can be defined away by adopting the session semantics. In other words, this incorrect behavior is simply declared to be the correct behavior. Okay. Now, the another problem that is unfortunately that cannot be defined away at all is that when the two files are written back to the server and one is written last will override the other one. One way to again solve this consistency problem is to use the write through algorithm. Means by using the write through algorithm, we can avoid the issues of inconsistency. Now, in this algorithm, when a cache entry is modified, the new value is kept in the cache, but it is also immediately sent to the server. As a result, when the another process reads the file, it gets the most recent value. However, some problems can again do exist. For example, suppose the client process on the machine A reads a file F. Now the client terminates, but the machine keeps F in its own cache. Then after, a client on machine B reads the same file, modifies it and writes it through to the server. And finally, a new client process is started up on the machine A, and the first thing it will do is open and read the file F, which is taken from the cache. Okay, now a possible way which can give you out of this is to require the cache manager to check with the server before providing any client with a file from the cache. Another trouble with the write through algorithm is that although it helps on reads, the network traffic for writes is the same as if there were no caching at all. Besides, many program creates the scratch files, then after write them, read them back and then delete them all in the quick succession. Here, the next step in this direction is to adopt the session semantics and only write file back to the server after it has been closed. This algorithm is called as the write on close. तो ये दूसरा वर्जन है, that is the write on close. A completely different approach to the consistency is to use the next algorithm, that is the centralized control algorithm. Here, when a file is opened, the machine opening it sends a message to the file server to announce this particular fact. Okay, now the file server keeps the track of who has which file open and whether it is open for reading or writing or for both the cases, that is for reading as well as for writing. Okay, now if the file is open for reading, there is no problem with letting the other processes open it for reading, but opening it for writing must be avoided in these circumstances. Now again, when the client tries to open the file and the file is already open elsewhere in the system, the new request can either be denied or it can be queued in the queue. Alternatively, the server can send an unsolicited message to all clients having the file open, telling them to remove that file from their caches and disable the caching just for that particular file. Even with these precautions, one must be careful. In particular, if a machine opens, catches, and then closes a file, upon opening it again, the cache manager must still check to see if the cache is valid. Okay, so the four cache management algorithm can be summarized in the figure given in your screen. That is the method. First one is the write through. Now the major points that has to be taken into account as far as the write through method is concerned works but does not affect the write traffic. Second method, that is the delayed write, again give you the better performance but possibly ambiguous in semantics. Then after the third, that is the write on close, again matches session semantics. Then after the last one, that is the centralized control, again it can be used for the unique semantics but not robust and again scales poorly to the larger problem solutions. So these are the four algorithms for managing a client file cache. Okay, so students, these are the various points as far as the cache consistency is concerned. Thank you.